Good evening, Shreya Shri.
Good evening, ma'am.
Good evening. Good evening, children. Hitesh, what happened? Last two classes. All right, children, please listen. Yeah. So ABC is a right angle at A. Yeah, come. Yeah, yeah. Yes, yes. So triangle ABC is a right angle at A. DEFG is a square, which means all the sides are equal and every corner is a right angle. We have to prove that this triangle is similar to this triangle. Then this triangle is similar to this triangle. Also, this triangle is similar to this triangle. We can see three triangles, right? Like the whole triangle, we have the whole triangle. Apart from that, we can see three small triangles. So I'll show you again. You will have to prove that. So we have to prove that this triangle is similar to this one first. Then we have to prove that this triangle is similar to this one. That is second. And third, we'll have to prove that this triangle is similar to this one. And fourth, we'll have to prove that DE square. We'll have to prove that this one. We'll have to prove that DE square is equal to BD into EC. These are the four things we'll have to prove with the given information. Now the numbers, we do it whenever needed. You cannot mark off like this. As soon as you start the proof, you cannot mark all these numbers. You please draw the diagram in your answer paper and mark off the angles whenever needed. All right. So as and when you need, you go back to the figure and mark the angles. So first, to prove that these two triangles are similar, this one is similar to this one. This is in triangle AGF, this is 90 because it's given. This is 90. In this triangle, angle 2 is 90 because this is square, right? This is square. So angle 2 will be 90 degrees. So 90. Then corresponding angles are equal. Parallel line, transversal. Corresponding angles are equal. So which are the parallel lines? GF is parallel to DE. GF is parallel to DE because they are the opposite sides of the square. They are the opposite sides of the square. If GF is parallel to DE, it means GF is parallel to BC. So that way you have, see here, I'll extend this. See here, parallel lines and transversal. This is transversal. This is transversal. Can you see? See here? Parallel lines, transversal. Angle 3 is equal to angle 4. Corresponding angles are equal. Correct? 3 is equal to 4. Corresponding angles are equal. So the two triangles are similar by AA similarity criteria. Okay, so from what's the time now? 8:15 dot, you should finish. Okay. Leave your bag and other things on this side. So they're similar. All right. Okay. So when two pairs of angles are equal, the third angles are automatically equal. If you want, you can mention them. That is angle 3 of the angle 3 of this triangle AGF will be equal to not 3, sorry, angle 6. Angle 6 of triangle AGF will be equal to angle 8. The third angles, angle 8 of triangle BDG. If you want, you can mention that, or you can just say AA similarity. They're similar. So the first one is over. Now for the second one, take up triangles AGF and EFC, correct? AGF and EFC. So here again, in triangle AGF, angle 1 is 90. Here angle 5 is 90. All right. And then again, corresponding angles. Angle 6 is equal to angle 7. Corresponding angles are equal. So AA similarity, the two triangles are similar. Next, we'll have to show that these two triangles are similar. This triangle, this one and this one. Okay, so now when you can directly give this result, like when triangle 1 is similar to triangle 2 and triangle 1 is similar to triangle 3. From this, it implies that triangle 2 is similar to triangle 3. You can write this. But what if they ask you this one only? What if they ask you only this? Now we have 4 subdivisions. Supposing they don't ask you all the 4, you are asked to prove only this is similar to this, then what will you do? That is why we have proved like this. If supposing you have to prove all the 4 divisions, then yes, you can do this one. For the third one, you can say, since triangle 1 is similar to triangle 2 and triangle 1 is also similar to 3, comparing these two, we have triangle 2 similar to triangle 3. So here that common triangle. So here the common triangle is the one on the top, AGF. So we have here AGF is similar to DBG. We have the same AGF similar to EFC. So DBG, comparing DBG is similar to EFC. So that third one you don't have to prove. The third subdivision, because this triangle AGF is similar to DBG and EFC. From these two results, we have DBG similar to EFC. All right, from 1 and 2, third one you get. But what if they ask you to prove only this result? Then you should do this. Then you should do this. So you can see the numbers marked there. What you should do is you should mark all the angles in the 2 triangles. Mark off all the angles in the 2 triangles. So 2, 4, 8, 5, 7, 9. We have to prove that these 2 triangles are similar. So mark off all the 3 angles. Okay, 2, 4, and 8, 5, 7, 9. All right. Now, angle 4 plus angle 7. You should have one equation which is common to both the triangles. That is the equation which you will be comparing. Angle 4 is of one triangle, 7 is of the other triangle. So this becomes a common equation with which you can compare some other 2 equations. Because angle 4 is of one triangle, 7 is of the other triangle. So angle 4 plus 7 is equal to 90. Why? Because the whole triangle ABC, one angle is 90 degrees. In the whole triangle ABC, angle A is 90. So B plus C will be 90. So angle 4 plus 7 is 90. That's what you see here first. Angle 4 plus 7 is 90. Correct? In the big triangle ABC, one angle is 90. So the sum of the remaining 2 angles is 90. So 4 plus 7 is 90. Then come to the small triangle, this small triangle. 2 is 90 degrees. So 4 plus 8 is 90. Since 2 is 90, the sum of the remaining 2 angles, 4 plus 8 is 90. That's what you see in B. That's what you see in B. Then in this triangle, angle 5 is 90. So the sum of the remaining 2 angles, 7 plus 9 will be equal to 90. 7 plus 9 is 90. So now 4 plus 8 is only of this triangle. 7 plus 9 is only of this triangle. But 4 plus 7 is equal to 90 is an equation common to the 2 triangles. So compare B and C with A. Don't compare B and C. Compare B and C with A. Why with A? Because A is the one which has one angle of one triangle, another angle of the other triangle. So that becomes the common equation. So compare B and C with A. So when you you can see from A and B, from A and C. From A and B, you can see here, no, I've written here. From A and B, from A and C. Okay, so from A and B, 4 plus 7 is 90, 4 plus 8 is 90. So 4 plus 7 is equal to 4 plus 8. So 4 on either side gets cancelled and angle 7 is equal to angle 8. Angle 7 of the this triangle is equal to angle 8 of this triangle. Now compare B and C. Sorry, A and C. Now compare A and C. A and B, A and C. When you compare A and C, 4 plus 7 is equal to 7 plus 9. So 7 gets cancelled and we have 4 is equal to 9. So that is 4 is of one triangle, 9 is of the other triangle. Correct? And you already have one information, angle 2 and 5, 90 degrees. You can write that also. So now this ABC, no, it's enough if you write A and B also. You don't have to write C. Write one common equation, 4 plus 7 is 90. With that, another one is enough for double A. Because we already have angle 2 is equal to angle 5 is equal to 90 degrees. So we want one more, that's all. So it's enough if you write A and B. This is just to learn. So we have written all the 3. B and C will not help. Either write one common A and B or A and C. With that, you will get one result. Double A you can do. Or now we have shown triple A here. Okay, so now the triangles are similar. So we proved similarity everywhere. Now to get the last result, D square is equal to BD into EC. Take up the third one, this similarity. this one and write the proportion. I've written the proportion. Okay, I've written the proportion. In the proportion, I have BG and FC. See, look at BG in the figure, BG and FC. They're not relevant to the result. So I took it away. Meaning you have your DE, BD and EC, no? That BG and CF, they're not relevant to the result. You can compare. You will have your time, so you compare. That they're not relevant to the result. So I took it off. Now, what do you need in the result? Can you see BD and EC? So we have here BD, DB and EC we have. When you cross multiply, can you see? When you cross multiply, you will get that BD and EC. So one part you have. You have BD in this ratio, EC in this ratio. That you can also take it like that. That's the reason why we go ahead with this ratio and this ratio. We have BD in this and EC in this. See, we need BD and EC in the result. And we have BD here and we have EC down here. So we'll go with only these two ratios. That's what I've written down. But you need to get, okay, we got DB and EC, but we should get DE square. Now come back to the square. In a square, all the sides are equal, right? In a square, all sides are equal. So GF is equal to GD is equal to DE is equal to EF. So what do you have here? You have EF and EF and DG. EF, see, I'm not doing this one. I'm not working with this. So in the next step, please see carefully, DB and EF, no? Instead of EF, I've written DE because all the four sides are equal. See, we want BD in the result. The numerator BD, this one we want. We don't want this EF. So instead of EF, I've written DE. I've written DE. And then here DG, we don't want DG. We don't want DG. So instead of DG, I've written DE. All the sides are equal. So instead of DG, DE. EC we want. We want two things. We want BD and EC. We don't want the other two. The other two are the sides of the square. So take it away and replace it with DE, which is also the side of the square. Now when you cross multiply, you get the proportion. Sorry, you get the equation. All right, please complete. Oh, good evening, Ananya, Shreyas, Priyasha, Subbalakshmi. Good evening, ma'am. Good evening, ma'am. Good evening. The first answer, the question you don't see here for children who couldn't join on time. I'll send the question later. I'll send the question, or maybe this whole thing I'll work again at home and send it on WhatsApp. Done, children here? All of you? Okay. Online students?
Completed, ma'am. Completed one.
Okay. On the board, I can draw better, but this one, please excuse me. This one I cannot erase. If I erase, the whole line will get erased. This is not there. I can't erase this alone. This one is not there. Ananya, you missed the last two sessions. You normally text me, but you did not.
The last session, one session.
One session, no? Okay.
Yes. I was caught up with my pre-board exams. I forgot to text you. Very sorry.
No. Okay, fine.
It is ending on Monday. No issues.
Okay. But you're still to watch the recording, is it?
Yes, ma'am, I have to. After this exam gets over on Monday, I'll make sure to watch them.
AHOPBKM. Okay. So what do you see? A circle, AB diameter because it passes through O. AM is the extension of the diameter AB. Because there's one, 2-3 lines are there, we won't write all that. So we can see from the figure, we understand that AB is the diameter because it passes through O. And AM is the extension of AB. AH is perpendicular to HM. AH is perpendicular to HM because it's marked 90 there. And also BK is perpendicular to HM. It's marked. Okay. With all this, we need to show that AH, this is what we'll have to prove. To prove that AH plus BK is equal to AB. AH plus BK is equal to AB. What do we get Z here? Oh, here this R minus Y here, written Z. Sorry. When you take out R by Z is common. R minus Y. R minus Y. R minus. Z is common, so R minus Y. Z is equal to R by R minus Y. X minus Y. R by R minus Y. So 2x minus y is equal to 2r minus 2y. Finished writing, online students? All right. Please complete and let me know. Finished? Yeah, online students. Lakshmi, Shreya Shri, Shreyas, Ananya, and Priyasham.
Completed, ma'am.
Okay. Okay. So what was marked in the figure? Only radius OA, OB and OPR. Only that was marked. The others we marked. Okay. So now again we just use similarity. We prove that two sets of triangles are similar, and by comparing, that's what we always do. We show that one pair of triangles are similar, another similar proportion, comparing proportion. This is the procedure we always use. One pair of triangles similar, another pair similar. So from the similar triangles, we write the proportions, and we do something with the proportions to get the result. Okay, so here we'll take up that small triangle MBK. Okay, we identify three triangles like this: MBK, the smallest, and then MOP, and then MAH. Okay, so we identify these three triangles: MBK, the smallest, and then MOP, and then MAH. So we take MBK to be the common triangle. That is, we are going to prove that MBK, the smallest triangle, is similar to the other two triangles. The smallest triangle MBK, we prove is similar to MOP as well as MAH. And that is easy because one angle is a common angle. One is a common angle and then 90 degrees. Not B, sorry, whatever it's B, I wrote BPO. My God, not BPO. Nobody tells me if I'm wrong. Is it BPO, children? What is it? POP is 90. Huh? What's 90?
KPO or OPK.
KPO is 90. KPO. KPO is 90. How do you name that angle? KPO. KPO is 90. Radius OP perpendicular to the tangent. All right. So that's the only thing we have to write using the theorem. After that, take up the two triangles, the small one MBK and then MOP. Show that they are similar, common angle and 90 degrees. Then write the proportion. In similar triangles, corresponding sides are proportional, and write all the three ratios. Write all the three ratios because we don't know which one to ignore. So write all the three ratios. Okay, and then see, we'll ignore the one which comes here. We'll ignore the ones, if the line segments come on this one, HM, we'll ignore it. Because HM is not a part of the result. What do we have in the result? We have AH. We have AH. So you want AH. Whichever ratio has AH, you want it. And we want BK. If a ratio has BK in it, we want it. And then we want AB. AB is AO and OB. Or maybe anything on the AM we want. Okay, let me put it like that. AM or anything on AM we want because we have AB. We have AB. So AB, this line segment AM, we want that. And we also want AH. We want OP because that's also the radius. See, you can ignore only one line segment on which we have the ratio. So that is HM here. We'll totally ignore HM. So if you can see here, this one is MK by MP. This one is MK by MP. MK by MP. So ignore it. Understand? Am I clear? MK by MP, just leave it. Then now substitute for these. What is this one? KB by PO. So that is Y by R is equal to, children, this you please see and understand. Triangle is similar. So corresponding sides are proportional. In these three ratios, ignore this one. Substitute for these two ratios from what you have marked, because it's difficult to understand with KBPO. So at this point, you should go back to the figure and mark XYZ. See, you don't know when you start off, you don't know. How do you know that you'll have to mark this as X, this as Y, and this as Z? I don't know. We don't know. Don't mark. Get started first. And then you will know where to mark. Now, after writing this proportion, KB, where is KB? So you want to call it X. There's KB, no? So call it X. I have called it Y, but I'm just telling you. So if you haven't marked anything, now you go to the figure where you find KB, mark it X. PO is the radius. So let it be R. Then MB. You understand what I'm reading? MB. What is MB? MB. It's not marked. So mark it Z. Okay, or Y. Then MO. MO, don't mark simply something. MO is already If you had marked, okay, I have marked it Z, so Z plus R. Z plus R. So children, X, Y, Z, you cannot mark as soon as you see the figure. When you need, you go back to the figure and mark it. So that's how we got this one. Now what you'll have to do is we want, okay, what is this AH made up of, children? What is AH? AH is like here in this figure it is X. What is BK? BK is Y. And what is AB? What is AB, children? It's in R or it's 2R. So you can see that we have used the letters X, Y, Z and R. But you don't see Z in the final result. That is why we write this equation in terms of Z. That's all, because how do you know? Why we can't write as X is equal to or Y is equal to, Y, Z is equal to? Because when you look at the result which you have to prove, AH is X. You see the figure? AH we have called it X. BK we've called it, where is BK? Yeah, Y. And AB is 2R, which means we have 4 letters X, Y, Z and R in the figure. But you don't see Z in the final result. So we will write the equation, cross multiply and write the result in terms of Z. Like we'll write Z is equal to something. That's what I've done here. Z is equal to. So there are 2 terms with Z. There are 2 terms with Z. We have YZ and ZR. There are 2 terms with Z. So you have to take out Z common. So you'll have to have them on the same side. When you have to write it in terms of Z, but of the 3 terms, 1, 2, 3 terms, 2 terms have Z in them. So that means you should have those 2 terms with Z on one side, any one side. So see ZR, YZ. Why we have gathered those 2? Because both of them have Z in it. Then take out Z common. Then Z is equal to RY by R minus Y. All right. Yeah. So this is the first result. Then take up the little triangle MBK and the big one MAH. Same thing, common angle 90 degrees, similar proportion. And again, the line segments that come on MH, you ignore it. So MK by MH will ignore that. And for the others, we have substituted. You can see MA. What is MA? MA is Z plus 2R. MA is end to end. See, MA from here to here. So 2R plus Z or Z plus 2R. So this is substituting. All right. Here also we'll have to write Z is equal to. So cross multiply. Again, there are 2 terms with Z. There are 2. See, I've worked here. I've continued here. Okay. There are 2 terms with Z. You can see YZ and XZ. So take them onto one side and take out Z common. And then write Z is equal to. All right. So that is 2. That is 2. Now from 1 and 2, now when you equate 1 and 2, because we have 2 expressions for same Z. For Z, we have 2 expressions. So they equal, no? So from 1 and 2, we get RY by R minus Y is equal to, right on top of work. Right on top of work. So RY, this one is equal to this one. This one is equal to this one. This one. So now you can see that result, it does not have Z at all in it. It has only X, Y and R. It has only X, Y, R. It doesn't have Z. Z is gone now. Now when you cross multiply and simplify this, you will get that result. We got X plus Y is equal to 2R, which is nothing but AH plus BK is equal to 2R is AB. So remember this like a story. How do you remember this like a story, like exactly what we like just heard? So 3 triangles. One is the smallest. So prove that is similar to the other 2 and write the proportions. So we have 2 proportions, meaning we write the proportion from one similarity and another proportion from the other similarity. And then since that MH is not used, so we just ignore the ratios that come on that line segment MH. For the remaining, you mark of X, Y, Z. We already have R. For the others, we mark of X, Y, Z. Then after substituting and cross multiplying and looking at the result, we understand that we don't meet Z in the final result. We are working with X, Y, Z and R. But we realize that Z is not needed in the final result or is not happening in the final result. So we decide to write the equation in terms of Z. So do that in the first one and the second one. Write both the equations in terms of Z and equating, you get the final result. So the question can, this is an idea. This is an idea. You can use the same idea in some other sum like this. So you should remember this idea. It's not about only if this comes, you can do this. This procedure is important. That's what I'm trying to tell you through this sum. This idea of similarity proportion, and which one to neglect and which one to go ahead with. So Z is not needed. So that idea is important here. That is what I'm trying to tell through this sum. It's not about, okay, I understood this sum. This idea can be applied in different situations. Remember the idea. Yes, sir. Sorry. AOPH. No, how do you prove that this one is a square? AOPH? And PO and AO equal radius. Okay. And force 90 degrees. And O AH and answer OPH 90 degrees. How? No, that is not, that's not a tangent. AH is not a tangent. The AH is a secant. Yeah, it cuts through the circle. It cuts through the circle. That's what I see in the figure here. Yeah, it comes inside the circle. It comes inside the circle. I'll show him because he's closer to me. Can you see? It comes inside the circle. Finish writing, online students?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yeah. Again, I'm not writing the details given. I'll tell you as I draw the figure. Circle. Circle. Tangents. Okay, tangents. Now I cannot erase this, okay? So please ignore this. I cannot erase this part. Center. These are tangents and the points of contact P and Q. This is also a tangent. AB is also a tangent. AB is also a tangent at E. This point is T. AP, PO, OQ, BQ, EA, T. Yeah. Yeah. So TP and TQ are tangents at P and Q. AB is also a tangent at E. AB is also a tangent at E. It's given the radius is equal to 5 centimeters and OT is equal to 13 centimeters. Find AB. The question is to find AB. All right. Finish it then. So we know that, you can just mention the triangle of TEA is similar to, is congruent to triangle TEB by ASA. ASA conference criterion. So EA is equal to EB. Therefore, EA is equal to EB. You don't have to write the details. This is enough. Because in these two triangles, you can see that this angle is 90, no? This is 90. This will be 90 and this is also 90. Okay, angle TEA is equal to TEB is equal to 90 degrees, correct? Because that side is 90. Angle 4 is 90. Angle 4 is 90 by radius perpendicular. No, look at the boards. Angle 4 is 90 because radius perpendicular to tangent. AB is given to be the tangent at E. AB is given to be a tangent at E. So angle 4 is equal to 90 degrees, radius perpendicular to tangent, correct? So that means angle 2 90 degrees. Can you see that I've marked 2 above E? I've marked 2 above E. So angle angle 2 is 90 degrees. So that means the adjacent angle, this also will be 90. So in these two triangles, you can see 90 degrees and ET is the common side. And this angle is equal to this angle because equal tangents are equally inclined. This angle will be equal to this angle. Equal tangents are equally inclined to the line segment joining the center and the external point. So by ASA rule, the two triangles are congruent. CPCT, you will have EA is equal to EB. So we found EA, and when you double it, you get AB because EA is equal to EB. And AB is EA plus EB. AB is EA plus EB, but EA is equal to EB. So find EA and double it. And also you're given OP is 5, radius is 5, and OT is 13. So using Pythagoras theorem, PT is equal to 12. PT is 12 using Pythagoras theorem. Because OT is 13 is given. And OP is 5. And OPT is a right angle at P, because radius perpendicular to tangent. It's not given, but we know that by the theorem. Angle 1 is 90, correct? So by Pythagoras theorem, PT is equal to 12 centimeters. Are you simply nodding your head without following? Repeat what we're talking about. Loud. In which triangle are we applying that? A? Pace is the index of the mind. Pace is the index of the mind. At this point, you were not listening. You were just nodding your head. இதுக்கு முன்னாடி என்னன்னு தெரியல. நான் பார்க்கல. நான் பார்க்கறச்சல you were just nodding without really following what we're talking. You're running something else in your mind. Your friends are playing cricket in the playground? No. You're missing some cricket match on the television? No. Your favorite movie on the television now? No. Then what are you thinking about? Dinner at your restaurant? Focus, don't waste time. We are talking about triangle OPT. Oh, the board is not clear to you? Come, please change your place. What about the others there? Hitesh? Is it better now? Is it still there or better? Better only, not good. Okay. So in triangle OPT, angle 1 is equal to 90 degrees. Okay, I'll leave you in this sum. Next sum I'll ask you, okay? Yeah. So we apply Pythagoras theorem in triangle OPT and find PT. All right. And then we know that OE is 5. Why OE is 5? Because radius. OE is the radius, so it is 5. How much is the OT given in the question? 13. OT is given to be 13. So how much is ET? 13 minus 5. ET will be 13 minus 5, 8. So much you know. 12 we got using Pythagoras theorem. And this 8, ET is 8 by subtracting 13 minus 5, 8. So with all this, we'll start. And we also know that to find AB, it is enough to find EA or EB. EA or EB. You can find EB also by proving that the other two triangles are similar. You can also find EB. So we have found EA. Simply take the two triangles, TEA, the small one TEA and the bigger one TOP. Show that they are similar. One common angle and then one pair of angles equal to 90 degrees. So double A similarity, the similar proportion, substitute, and you'll find EA. Double it to find AB. Online children, finish writing.
Yes, ma'am.
Okay, good. Yeah, try this one, children. Raja, it's time. Please come. Stop writing. Finished. Okay. How many more to go? Two more. Huh? Okay, sir. Very good. Looks better today. Okay, come here. No problem. Another 15 minutes. Yes, what's answer? Very good. 1,94,400. Very good. Very good. Same thing. Let me see your working. Correct. I'll just see how the method is. Just pass the book to Deepika, pass your book to. Thank you. Oh, correct. Okay, nice. Yeah. Very good. Okay. So if the sum of the, so simply make them, some equations. So if the sum of the LCM and HCF of two numbers is 1260, so you can just, call the HCF. You can, okay, see, you can do this. Let LCM be X and HCF be Y, okay? Not the two numbers. The two numbers are not X and Y. The LCM of the two numbers is X, the HCF of the two numbers is Y. Okay, what is given? The sum of the LCM and HCF. So that means X plus Y is 1260. So this is one equation. Yes or no? And then their LCM is 900 more than their HCF. LCM is more than the HCF. By how much? By 900. That means LCM minus HCF is 900, right? LCM is 900 more than their HCF. LCM is more. HCF is less. What is the difference? 900. Okay, so you can also write HCF plus 900. HCF plus 900 is equal to LCM, you can write. Or you can write LCM minus 900 is equal to HCF. Anyways, you can construct the equation. HCF plus 900 is equal to LCM, you can write. Or you can write LCM minus 900 is the HCF. Anyways. All right, so now on solving these two equations, you get 2x is equal to 0,612. So x is equal to 1080. So substitute and get the value of y. Therefore, y is equal to how much? 180. 180. So now the product of the two numbers. Then find the product of the two numbers. So you got the what is this? The HCF. Sorry, what are x and y, by the way? LCM and HCF. Yeah, now how do you find the product of the two numbers? Product of the two numbers is equal to LCM into HCF using that relation. Okay, product of two numbers. Product of two numbers is equal to HCF, or you can say LCM into HCF. LCM into HCF. So that is LCM is X, HCF is Y. So 1080 into 180, which is equal to 1,94,400. Get your book here. Pass your book. You got the same solution? Sorry to trouble you. Nine hundred is the okay, 900 plus X. Okay, 900 I understand. X is what? LCM or HCF? You've not mentioned that. X is the HCF. Okay. LCM and this is equal to 1260. Correct. Yes. X is equal to 180. So if X is 180, the other number will be plus 900. Perfect. Very good. So we got the LCM and HCF. The product of the two numbers will be LCM into HCF. That's the relationship between the two numbers and their LCM and HCF. Right, children? Done, online students? Yes. We also discussed it. So yeah. Okay, so A and B are two positive integers. A and B are two positive integers such that the least prime factor of A is 3. The least prime factor of A is 3. So one thing we can conclude from this information is that 2 is not, see, 2 is the smallest prime number. 2 is the smallest even prime number. Smallest prime number, smallest, and okay, not even the smallest even prime number, that's the only even prime number. 2 is the only even prime number. All the other prime numbers are odd. All other prime numbers are odd. And 2 is the smallest, 2 is the smallest prime number. 2 is the only even prime number. Okay. So if the least prime factor of A is 3, that means A is not even, correct? Because if A is even, then it will have 2 as a prime factor. So what can you conclude from this? The smallest prime factor of A is 3. That means A does not have 2 as a prime factor. If A does not have 2 as a, because the least prime factor is only 3. So it does not have 2 as a prime factor. If it does not have 2 as a prime factor, that means A is odd. It's not even. Because if it was even, then it will have 2 as the least prime factor. So A is odd. A is odd. Then coming to B. B also, the least prime factor of B is 5. So again, B does not have 2 as a prime factor. So see, numbers are either even or odd. Numbers are either even or odd. If it is not even, it has to be odd. There is no choice. There's no third thing or fourth thing. Numbers are either even or odd. So B is not even. Why? Because it does not have 2 as a prime factor. So it's not even. So it is odd. So what is the sum of A and B? Odd plus odd. What is the sum of A and B? Odd number plus odd number. What is the result of an odd number plus odd number? It's an even number. So that means A plus B is even. A plus B is even. Then what will be the least prime factor of A plus B? 2 will be the least prime factor of A plus B. You cannot find the numbers. You cannot find what the numbers are, but you can always find the least prime factor of A plus B. So since A plus B, we don't know the numbers A and B, but the sum of these two numbers, both are odd. Both A and B are odd numbers. Whatever they are odd. So when you find A plus B, when you find their sum, it is even. If it is even, then the least prime factor will be 2. So the least prime factor of A plus B is 2. So this you can write in your own words. Write the answer. I'll write in my style. You can also do it in your own way. And children? Yeah. Yeah, try this one, children. Somebody's mic is enabled. Please disable your mic. Yes, children. Any guess? 1. Okay, Hitesh says 1. Zero. How do you feel you've done? Sorry? No, you must know. You should be able to judge yourself. You don't know the answer, but see, when you finish the test, you should know. Based on your preparation, you will be able to evaluate yourself, right? Because they're not, the questions are not new to you. You've already practiced the same questions. So you should be able to judge. No? Okay. You've done well. So how do you find the value of x squared minus y squared?
First we have to find x plus y, then we find x plus y.
Very good. That's all. That's what I want. That means you've understood. Very good. All right. See. So the tuition of it is. I'll give it to you tomorrow without failure. Yeah, see. You're coming tomorrow, right? Yeah.
So
I can't hear you.
I'm going to submit 3 test papers and I think I'm going to wait on.
Okay.
So yes,
You need some more. Okay, fine. I'll send. I'll send you. You want to choose the chapter? I'll send it. Anything's fine. All right. Fine. Yeah. What's answer? 1, 0, then 1. Okay. So if you see 6 raised to any power will always end with the, see, n is a natural number. Okay. N is a natural number. So 6 raised to any power will always end with 6. You can try that. 6 to the power 1 is 6. 6 square is 36. 6 to the power 3 is 216. So it always ends with 6. Similarly, 5. 5 to the power 1 is 5. 5 squared is 25. 5 cubed is 125 and so on. So 6 raised to any natural number will always end with the digit 6. And this one will always end with the digit 5. So 6 to the power n. So supposing 6 cubed minus 5 cubed. So it will be 216 minus 125. Whatever be these, 6 minus 5, 1 you will get. So it will always end with 1. It will end with 1. The difference is not 1. The difference will end, the units place will be 1. Yes or no? All right, write down, children. So you are right, yeah. You took what common?
In the power in this common.
What to the power n is common?
6 minus 5. Whole power n. So,
Oh, 1 minute. How did that become 6 minus 5, the whole power n? So you're like saying a square minus b square is a minus b the whole square. Your answer was right, but the approach was, meaning the way.
based on square minus a square.
No, you cannot write it. The first place 6 to the power n minus 5 to the power n is not 6 minus 5 the whole power n. Is this okay? Huh? Oh. 0 is possible only when the power is 0. 6 to the power 0 is 1. 5 to the power 0 is 1. 1 minus 1 is 0. No, actually, you think out of the board, out of the box. So really, you will become a great person in life. No, really. There are some students who will study only with the concepts, but some students don't want to accept the concepts. They go outside it and learn. So really, keep in touch, okay? You see, this will come true. So anyways, that was right. You're right. Your answer is right. If it is a rational number, but for that, it's not one answer. Only in that case, it will be 0. Okay. Either 5 or 13. Either. Either 5. This is either. EITHER. Either 5 or 13. Class, use the emoji, raise your hands. Ananya, Priyasha, Shreya, and Lakshmi. You're there, Lakshmi?
Yes, ma'am.
Yeah, children? Any guesses? Five only. Give you some more time. Think. Okay, so the best way to crack such questions is to apply a number and see. The best way to crack such questions is just take a number and see the result. Take the smallest natural number. What is the smallest natural number? 1. Apply 1 and see. Yeah, apply 1 and see. What are you getting? What is 2 into 1? 2. 9 square is 81. When n is 1, 2 into 1 is 2. So 9 square will be 81 and 4 square is 16. What is the difference? 5, 65. And 65 is divisible by both 5 and 13. Just check one more. Now when n is 2. Okay, when n is 2, 9 to the power 4 minus 4 to the power 4. 9 to the power 4, 81 into 81. 81 into 81. 6561 minus 4 to the power 4, 256. Minus 256. 6305 is divisible by 5, you know. It's divisible by 5 and is also divisible by 13. So the option is divisible by both 5 and 13. But I'll tell you what it is actually. Do this. Sometimes you just take the values, apply the values. 4 options are given. Apply the values in the expression or equation given and try to judge something. So here, since n is a natural number, it's not 0. Can't be 0. So 1, 2, 3, and so on. So you take the smallest one, 1 and 2, and see. It's divisible either by 5. The answer which you get may be divisible by either 5 or 13, not both. Both 5 and 13 means that number is divisible at the same time by both 5 and 13. Either this or that means if I ask you to take this or either this or that, you should take only one of the two. You can't take both. Either this or that. Okay, and the algebraic idea behind or the algebraic concept behind this is that a raised to any even power. 1 minute. Okay. Now, when you take a squared minus b squared, that is a, it's a difference. First is it's a difference. See, we 9 to the power 2n minus 5 to the power 2n. All right. 4 to the power. All right. So a square minus b square. So see, you're like this. This is the power 2n, meaning it's even, right? 2n is always even. 2n will always be even because you can see 2 as a factor there. 2 into anything will always be even. 2 into any natural number here is always even. 2 ones are 2, 2 twos are 4, 2 threes are 6, 2 fours are 8, 2 fives are 10. It's always even. So here the power 2n is always even. It's a difference. And the bases are different. The bases are different, 9 and 4. The bases are different, 9 and 4, like A and B. It is a difference. And the power is the same in both and it's even. It's 2n in both and it's even. So when you look at this expression and suppose you have to comment or say something about this expression, you can say all this. The bases are different, 9 and 4. Bases are different, but the powers are the same. 2n, 2n, the powers are the same. And it's a difference. It's a difference. So it goes with a square minus b square. Not only a square minus b square. See, it goes with this. I haven't finished because a, b bases are different. Power is even and it's minus. What are the factors of a square minus b square? A plus b is a factor. A minus b is a factor. Similarly, when you check for a to the power 4 minus b to the power 4, a plus b, because this can be factorized as a square minus b square into a square plus b square. How do you factorize this? How do you factorize? What are the steps? A square the whole square minus b square the whole square. Correct? So it is a square plus b square into a square minus b square. So you can see a square plus b square as it is, but a square minus b square is further a plus b into a minus b. So when the power is 4. Similarly, when the power is 6 or power is 8 or power is 10 or power is 12, you will always see a plus b and a minus b are factors. You will always see that a plus b and a minus b are factors. Are you following something? So that means for 9 to the power even number minus 4 to the power the same even number, 9 plus 4, the base, no, what is a plus b? The basis. A plus b, a minus b. So what are the bases here? 9 and 4. So 9 plus 4 and 9 minus 4 will always be factors. So 9 plus 4 is 13, 9 minus 4 is 5. So the option both 5 and 13 will be, it will be divisible by both 5 and 13. Now for a cubed plus b cubed, only a plus b is a factor. A minus b will not be a factor. A cubed plus b cubed. For a cubed minus b cubed, only a minus b is a factor. What are the two factors of a cubed minus b cubed? A minus b into a square plus ab plus b square. The algebraic identity. A cubed minus b cubed is equal to a minus b into a square plus ab plus b square. So a cubed minus b cubed, a minus b is a factor. A cubed plus b cubed, a plus b is a factor. But both a plus b and a minus b will be factors when the power is even. Like a square minus b square, a power 4 minus b power 4, a power 6 minus b power 6, a power 8 minus b power 8, a power 10 minus b power 10. In all these expressions, both a plus b and a minus b will be factors. So for this expression given in the question, the bases are like a and b. We have 9 for a and 4 for b. So a plus b, 9 plus 4. A minus b, 9 minus 4. I'm talking for this question. So 9 plus 4 and is 13 and 9 minus 4 is 5. So 13 and 5 will be factors. Am I clear about this one? Children understand that? You can either check with the value like what we did. We used 1, 2 and checked. You can actually find the values and check for 1 or 2. Or this is what it is. So prove that root 2 is an irrational number. You all know the proof by contradiction method, right? All of you. So the same thing is for 3, 5, similar. 3, 5, 7, 11, and so on. All of you do that now. Prove that root 2 is an irrational number. Write that proof by contradiction. So you can do that yourself using the procedures, the same in all schools.
If they're not given the first statement, that is prove that root 2 is irrational, they've just given show that 3 by root 2 is irrational. And if it comes in a 2-mark question, do we have to write the whole step for proving root 2 is irrational?
No, not needed. I'll tell you how you can do it in 2 ways. You don't have to prove that root 2 is irrational. Root 2 is irrational. Root 2 is an irrational number, is like a theorem. Root 2 is irrational, root 3 is irrational, root 5 is irrational. The square root of a prime number, is irrational, is a theorem. Root 3, 1 minute. Ananya, I'll come back to this question at the end of this one. All right?
Okay. Yes.
Yeah. Finished? How do you write? You write a square is divisible by 2 or 2 divides a square. How do you write? 2 divides a square. You can write it. Yeah, you can write it either ways. You can write a square is divisible by 2. So a is also divisible by 2. Or the other way you can write 2 divides a square. So 2 divides a. So we all use divides, is it? Divides na use pandroma. Okay. Online students, do you write a square is divisible by 2 or do you write 2 divides a square?
2 divides a square.
2 divides a square. Okay. Sorry. Yeah, a square can be substituted with 2b square, no? Yeah, a square is 2b square. So I've substituted. A square is 2b square. Substituting from here. A square is 2b square. So 2b square is equal to 4c square. 2 cancels. 2 ones are 2 2s are. So b square is equal to 2c square. So 2 divides b square. This implies 2 divides b. So don't make any changes in what you have learned in school, because this you have learned some format in school. So you stick to that. More or less it will be like this, right? Maybe what you write, the theory part may be a little different, but otherwise it will be the same. Okay. So prove that root 2 is an irrational number. We are done. This is the proof by contradiction. That is, it is not rational, therefore it is irrational. Okay, so this proof is called proof by contradiction. It's not, we assume the opposite. We assume it to be a rational number, but since we come across a situation which is a contradiction, it's not possible for root 2 to be a rational number, therefore it is irrational. So we're done with this. Now the second part of the question, hence show that. So now, okay, now let me talk about that. This is a theorem. If root p, if p is a prime number, if p is a prime number, then root p is irrational. Root p is irrational is a theorem. If p is a prime number, then root p is irrational. That means like root 2. Root 2. 2 is a prime number, so root 2 is irrational. 3 is a prime number, so root 3 is irrational. 5 is a prime number, so root 5 is irrational. 7 is a prime number, root 7 is irrational. 11 is a prime number, root 11 is irrational, and so on. If p is a prime number, then root p, square root of p, is irrational. P is a prime number and it is rational. P is a prime number and it is a rational number. If p is a prime number, then the square root of p is irrational, is a theorem. So supposing the first part was not given to us, prove that root 2 is an irrational number. Supposing that was not given, we only have to show that 3 by root 2 is irrational. we only have to show that 3 by root 2 is irrational. You can do it in two ways. Are you following me? So the first part is not asked. Prove that root 2 is irrational is not asked. Here it is asked, so we did it. If we only have to show that 3 by root 2 is irrational, and as Ananya said, if it's for 2 marks, so maybe the same thing if it's for 4 marks, even if it is not asked, we'll be forced to write it because you're scared if that's not sufficient. Like a theory question, we are scared that it's not sufficient for 4 marks. So maybe even if it's not asked, you decide to do both. If supposing it's asked for 4 marks, 3 by root 2, prove that 3 by root 2 is irrational. If supposing that is asked for 4 marks, then to be safe, yes, we'll have to prove that root 2 is irrational and then prove that 3 by root 2 is also irrational. But if it is for 2 marks, like Ananya asked us, if it's for 2 marks, you don't, and it is not asked, prove that root 2 is irrational is not asked. Don't do it. Don't do it. Then what should you do? You should do only this. Do only this. So you can do the proof by contradiction, or you can use the property of rational numbers. You can use the property of rational numbers. Okay. So now we have, if possible, let, what was that? 3 by root 2. 3 by root 2 be rational. Okay. Listen to this, all of you. If possible, let Emma? No, this is only an expression, no, so you cannot square it. Now, random method, we have 2 methods. I'm doing something else. No, you see both the methods, and then if it is different, what you've learned in school is different, we'll talk about that. So if possible, let 3 by root 2 be rational. Now, what do we know? We know that we know that a rational number into a rational number will always produce a rational number. Okay. The product of 2 rationals is all okay. You can write that. You can write it like this, or you can write both are the same. Okay. The product of 2 rationals. The product of 2 rationals is always rational. Is this correct? Is this correct? Yes. So now we have assumed, if possible, let 3 by root 2 be rational. So 3 by root 2 is rational. Okay, this we are not sure. We have assumed it to be rational, but we are sure that 1 by 3 is rational. Are you all sure that 1 by 3 is rational? Because 1 is an integer, 3 is an integer. Integer by integer is a rational number. 1 by 3, all of us are sure is rational. Now the product of these 2 rationals will be a rational. So this is a rational. No, we're just supposing it. If we've assumed that 3 by root 2 is rational. Now going by that, 3 by root 2 is rational. 1 by 3 is definitely rational. The product of 2 rationals is also rational. So 1 by 2 is rational. 1 by root 2 is rational. So far understood? Now, again, the product, we know that the product of 2, same thing, continuing with the same idea. 1 by root 2. See, now I know something is in your mind, like when you do something, you should do the same thing on both the sides. Why you're only multiplying by 1 by 3, you're not dividing. We're using the relation, we're using the property that the product of 2 rationals is always rational. So we have a rational 3 by root 2. We suppose that it's a rational number. And 1 by 3 is rational. The product is 1 by root 2, which is rational by the property. Yes or no? Now, continue with 1 by root 2. 1 by root 2 into 2. 2 is definitely rational. 2 is rational. 2 into 1 by root 2. What is that? The product of 2 rationals. What's the answer? Root 2 is rational. This is the contradiction. You should do something so that you get the result as root 2, root 3, root 5, root 7, root 11, and so on. Because only these you know by the theorem that they are irrational. It's like a theorem that root 2 is irrational. You can use this without proving it. What is a theorem? When we say a theorem, that means you can use it in different places without proving it. You don't have to prove it as irrational. Root 2 is irrational. No, 1 minute. Let me finish it. Children, see, please understand this. Root 2, we know is irrational. Root 3, we know is irrational. Root 5 is irrational. These results are like theorems. It's not in different theorems like this. The theorem is if P is a prime number, then root P is irrational is the theorem. If P is a prime number, then root P is irrational is the theorem. So by that theorem, root 2 is irrational, we know. Yes or no? Yeah. So, but now by this, relation we got, that is this property of rational numbers, we've got root 2. Now, what was I telling you? Do something, use the property of rational numbers. The sum of two rationals is always rational. The difference of two rationals is always irrational. Sorry. The sum of two, the sum, difference, product and quotient of two rationals is always rational, except when you divide by 0. Only division we have an exception. When you divide 5 by 0, it's not defined. Except for that, any operation performed with two rational numbers, will always produce a rational number. Correct? We're using that property. So now, okay, so we use this property, fine. With what idea should you work? You should do something so that the final result is root 2, root 3, root 5, root 7, like that. Here you have root 2 in the expression given. So you must do something so that you are left with root 2. So what did I do first? I wanted to eliminate 3. So how will you eliminate 3? By multiplying by 1 by 3 and using the property that product of two rationals is always rational. You understand that? So to eliminate 3, we multiply by 1 by 3 and we get 1 by root 2, which is rational by the property. Product of two rationals is rational. So 1 by root 2 is rational. Now 1 by root 2 is not a theorem. Root 2 is in the denominator. You need to get root 2 in the numerator. So what to do? Multiply by 2. What will you do? You want to get root 2. You don't want 1 by root 2 because you cannot apply the theorem. You want root 2. How will you get root 2? Multiply by 2. Again, 1 by root 2 is rational. So multiply by 2. The product of two rationals is always rational. When you multiply by 2, you get root 2. Now by this, root 2 is rational. But this is the contradiction. Root 2 is not rational. Root 2 is irrational. That we don't have to prove. We know because by theorem, if P is a prime number, root P is irrational. So you should say this is a contradiction. Here this is a contradiction. Why? Because of our incorrect assumption that 3 by root 2 is rational. Therefore, 3 by root 2 is irrational. This is what you'll have to do for 2 marks. If possible, you start like this. If possible, let 3 by root 2 be rational. Then you can write anything you can write. I think you can write this one. The product of two rationals is always rational. So then do this. Okay, so root 2 is irrational. This is a contradiction. This is a contradiction. Or you can write, but I'm coming back to you. But root 2 is irrational. Because if by the theorem, if P is a prime number, then root P is irrational by this theorem. If P is a prime number, then root P is irrational. It's a theorem. So by this theorem, root 2 is irrational. So this is a contradiction. This contradiction is because of our incorrect assumption. This contradiction is because of our incorrect assumption. Therefore, 3 by root 2 is irrational. So you can do it by the property of rational numbers. This is one method. We'll do the other method also and wind up the session for today. Yes, sir. Now, I want to finish the second method because at the end of that, you can ask a question. Is it related to this one? Okay, then ask me. 1 by root 2? Oh, sorry, you wanted a simplification part, is it? No, like 2 by, what is 2? Root 2 into root 2, right? 2 is root 2 into root 2. So root 2 and root 2 will get cancelled and you'll be left with root 2. I'm sorry, I thought you were asking, you wanted to say about a different method. 2 is root 2 into root 2, correct? So when you can cancel one root 2 and one root 2, another root 2 is left, correct? Done, children, online students?
Yes, ma'am.
Okay. Others? Shreya, Shri, Priyasha?
Yes, ma'am, completed.
Completed, ma'am.
Okay, fine. Lakshmi and Lakshmi, yeah. Done, Lakshmi?
Yes, ma'am.
Okay. So this is for 2 marks. You can do it like this by using the property of rational numbers, that the sum, difference, product, or quotient of two rationals is always rational except for that exception. Okay, this is the other method. The alternate method. Okay. So if possible, again, we start like this. If possible, let what was that? 2 by root 3. No, 3 by root 2. If possible, let 3 by root 2 be rational. Then, if it is rational, then 3 by root 2 will be of the form A by B, where A and B are co-prime integers, integers. Denominator B should not be 0. Now square on both the sides. So you will get 3 by root 2. Don't have to square this. Sorry. When it gets late, I forget maths. That's what always happens when parents are waiting and it's getting late and I have to wind up, I forget maths. Yeah. Now cross multiply, children. So what do you get? Now, okay. Now I'll tell you what we're using here. The property we're going to use here. The property is integers. Like when you use integers in any ways, you can only get a rational number out of them. You have some integers. You add, you divide, you multiply, you do anything. The result will be an integer, will be a rational number. That's what it is. Now cross multiply. So you get root 2a is equal to 3b. Now here the idea is you're going to isolate root 2. You're going to isolate root 2. Isolate that one which you know is irrational. So here root 2 is irrational. Isolate that. Have that alone on one side. You don't have to square here, sorry. You don't have to square here. I'll tell you where you have to square. When you have like root 2 plus root 3, in such cases you'll have to square. I'll tell you. Okay. So now here just cross multiply. And the idea with which we have to work ahead is that Isolate the part which you know is irrational. So root 2 is irrational, we know. So root 2 is equal to 3b by a. So now we have all integers on one side. A is an integer, B is an integer, 3 is an integer, because A and B are integers. See the assumption, A and B are integers. A and B are co-prime integers. So on the right hand side, you have A, B and 3. A integer, B integer, 3 integer, all integers. Then it is rational. Integers can only make a rational number. So the RHS is the RHS is made up of integers, and so it is rational. But on the other side, root 2 is irrational by the theorem. How can you have an equation? It's an equation. That means both the sides are the same. It's an equation. That means both the sides are the same. But here we have rational on one side, 3b by a, rational on one side, and root 2 irrational on the other. And it's an equation. So this is not possible. The situation cannot happen. And why has it happened? Because of an incorrect assumption. Therefore, it cannot be rational, so it's irrational. This is the other method. All right. All right, children, is it over? Yeah. Online students, any doubts? Class here? Any questions? All right, so that's it for today's session. Thank you. Good night. And Hitesh, it was, what about online students? Any questions?
No, ma'am.
All right, children,
No,
you can
ma'am.
finish writing and finish writing and you may leave the call. Thank you. Good night. Evening ஏதோ கிளாஸ் இருக்குன்னு சொன்னதால தான் லாஸ்ட் வீக் நான் வந்து 4 மணிக்கு முன்னாடி முடிக்கிற மாதிரி ஒரு விஷயம் நீங்க அட்டன் பண்றது நீங்க 2 கிளாஸஸ் வரல எக்ஸாம் தான் ஸ்கூல்ல 4 ஈவினிங் வச்சா வர முடியுமா இல்ல கிளாஸ் இருக்கும் இருக்கா வீக்குள்ள முடிச்சா வந்துருங்களா
Thank you, ma'am.
Yeah, thank you.
Completed.
Thank you. Good night.
Thank you, ma'am.
Thank you, children. Good night.
Thank you, ma'am.
Thank you, ma'am.
Good night. Thank you. Good night. That's it. Go to 7. Right on. 4 to 7. Okay. 7 to 9, which I remember. Yeah, good night. இல்ல அப்ப 3 o'clock முன்னாடி முடிச்சிட்டா வந்துருவீங்களா 1 to 3 வந்துருவீங்களா ஷூர் நான் அந்த டைம் பெற்றது எனக்காக தான் நிக்கிறேன் நீங்க வரலாமே பார்க்கணும் ஓகே பை இல்ல ஒருவேளை கொஞ்சம் if I make it like 3:30 to 4:30 or something can you come இங்கேயே போக முடியும் start at 4 o'clock. You finished? Yeah. It starts at 4. So you have to be there at 2:30 to 4:30. Then 3:45 calling now. Good now. Yeah, good night. But I need to be from 1:45 to 3:45. I try my best. Otherwise, நீங்க என்ன பண்ணீங்கன்னா நீங்க ஒரு கான்செப்ட் கிளாஸ் அட்டெண்ட் பண்ணுங்க அந்த ரெஸ்ட் ஆஃப் இதுக்கு மட்டும் மீட்டிங் யூஸ் பண்ணுங்க ஏன்னா எனக்கு அந்த டைம் முடியல நான் வந்து லாஸ்ட் டைம் 12:30 வச்சேன் from 1:30 till 1:30. I'm not able to, because Sundays is not, I'm not able to do the class in the morning. I want to do, but I'm not able to. So supposing it's like, in one, you can leave like, 3 4 something to leave. You can leave, and that for the remaining part of the class, you can use a recording. Or I can maybe send the pictures of the notes. You can write down and then use the recording. Okay, I'll try my best, but if it is not, please come, don't miss the class. Good night. Yeah, good night.
Okay.